Hey guys, had a little bit of an accident the other day. I got this here P-Touch, a Brother P-Touch label maker. They're sold in Japan but also in America. I think they're a bit of an older model, but you can still get them in Japan here. This is obviously the Japanese model with the Japanese writing there. But had a little bit of an accident at the data center with this. I was going to use it, so I plugged it in, turned it on, and let the magic smoke out. Turns out that the transformer, for some reason they've given us an old transformer style transformer, not like the newer switch mode power supply, but input AC 100 volts. I plugged into a 200 volt supply. I was working a bit fast, didn't take notice, and I just had to get something done, and I plugged in, and then I didn't get it done because I let the smoke out. So basically what's happened is this is smoked up. I've kind of cracked it open. You can see the dents there. I've given it a smack, and yeah, it's gone a bit how you're doing inside. You can see there on the end, we overheat it, we popped it, let the smoke out, so that's dead. I'm not even going to bother trying to fix that because nah, not even worth it. It turns out that, well, this was here was a 9.5 volt at 1 amp, 1.3 amp DC, not regulated, but it turns out that this can run at 9.5 volts up to 12 volts. So a 12 volt power supply is going to be easy to find. 9.5 volt, not so easy, but 12 volt switch mode power supply, I've probably got 5 of them sitting in a box behind me on the shelf, so not a problem getting a new power supply. But let the smoke out of here. So I've already opened up to have a look, and I have the offending circuit board here, and it turns out that I smoked this one. I don't know if you can see there, if that's going to focus properly, but there's a little bit of a blemish on the top where the smoke's come out. It's cracked open and let the magic out. So I'm going to replace that, but it's the marking is basically the package style. There's no actual real markings on there that tell me what that thing is, so I'm not sure what it is, which is a bit of a pain. I'm pretty sure it's a voltage regulator because that's a standard package for voltage regulators, and it would stand to reason that a voltage regulator, if overvolted, would smoke. If I've put this, what's that, 100 volts to 9.5 volts, that means I basically put 19 volts through, because at 200 volts, you're going to get double the voltage out. The transformer overheated, but before it died, I was getting 18 volts. So that's probably a VREG, voltage regulator, and it's gone pop. So I've got no way of figuring out what the output voltage that is supposed to be because it's dead, so I can't measure it. But not all is not lost, because I have a new one. Yay! Just as a coincidence, or maybe slightly instigated by this incident, we got a few more of these things, because they are not a bad little printer. They plug in through USB to your PC, so when we're doing the patch panels and stuff, we can make custom labels. We'll divide it up and put them on the patch panel, and it all lines up to the ports and everything. They're quite nice. I do like them. So I have got a brand new one, which I will not be plugging into 200 volts, but I will be opening it up, plugging it in with the newer style switch mode power supply, which is also only rated to 100 volts, but it's a lot lighter, a lot smaller, a lot less chunky. I do like this a little bit better. So I'll plug that in, I'll take this apart and hook it up to the multimeter, see what voltage comes out of here on this one, and then I can get an appropriately rated voltage regulator. So I guess we will open this one up. So I'll get all this set up, I'll get my bench cleared, I'll get this set up, and we'll see what voltage we're getting. Okay, so first I'm going to do a continuity check, because I want to check to see if this tab here is ground. It looks like it's the ground plane, so I'm just going to double check that. Now this is a center negative, so I'll go to the center pin, and we're getting a beep, so that is ground, and that center pin is to the tab, so it is looking more and more like a voltage regulator. So let's plug this in, and we should get, between that tab and one of the legs, we should get 12 volts. Oh, I've got to turn it to DC volts. Yep, 12 volts there. And then on the other side, on the other leg, we should be getting something. What do we get? 3.3 volts. It's a voltage regulator, 3.3 volt voltage regulator. Jelly bean part, easy to get, cost cents, like 20 cents or 50 cents or something, probably for one of them. So that I will replace, but the one on this board. So that one there, 3.3 volt voltage regulator, standard part, easy. So hopefully by replacing that, we can get this one working again. So I'll go and source one of those. I'm not sure if I actually have one on the shelf, but I can get them from Akihabara or even DigiKey or Mouser. So I'll get one of those, and let's see if we can make it work. There is one more thing we have to take into consideration, that is the current draw. A lot of the parts, you can get these SOT 223 packages in like 1 amp, 1.2 amp, 800 milliamps, that sort of thing, from National Semi and Texas Instruments and all that sort of stuff. But there is one little hiccup, and that is that this footprint is non-standard. So I've desoldered that. Really easy to do. I just blob the solder on one side with a soldering iron, let it heat up, and then use some tweezers just to lift that away, and then go to the other side, blob the solder on, and then you just lift it away straight off the circuit board and clean it up. I've got a desoldering gun, but you can use a solder sucker or some solder wick and give it a bit of a clean with some isopropyl alcohol, and it comes up looking nice and ready for the new one. So the problem we've got here though, that's going to focus, is that if you look just above my finger there, it says IGO, input, ground, output. Now the common footprint for these is input, output, ground, which is a bit of a pain because, I mean, you can get them real cheap, 50 cents or something if it's input, output, ground, but not many at all are input, ground, output. I did find one on Mouser, and it's a 3.3 volt output at 200 milliamps, not the 1 amp or so of the standard footprint from Texas Instruments and the like. So we've got to figure out if 200 milliamps is enough. I'm going to assume that it probably is, because that 3.3 volt is probably just for the logic here and there, and for the microcontroller. All of the other stuff like the motor and that will be running straight off the 12 volts, and the screen's probably running off 5 volts or something. So I've got this set up actually already. You can see there I've got 2 wires. What I've done is I've lifted the output pin, and I've soldered one of these wires to the pin and one to the pad. So if I have nothing connected, it's not going to turn on. But because I've got these wires connected through to my ammeter, that's in line, it's in series. So anything that this circuit draws from the 3.3 volt rail will be measured by my multimeter. So if we plug that in, we'll be able to see what power draw. So I've got to put this all back together, because to control it, I need the screen and the buttons. So let's see if I can get this all together. Okay, so that looks like the screen, I think, yep. And then the buttons, I'll plug that in. Alright, push, there we go. Okay, so if I plug that in, we might get some like just standby current. And we are getting 45 milliamps. So that's looking good so far. And if I turn that on, 50 milliamps. Let's print something here. So I've got NFM on the screen, near far media. We'll print that out. Hit the print button. Printo. That's not what it says. It says print in Japanese. I don't know how to say print in Japanese. So it looks like we've got a maximum of about 55 milliamps. So that 200 milliamp part will be perfect. So off to a Mouser to order that part, and then we should be able to get this thing fixed. No worries. Alright, finally got my new part from Mouser, the new little regulator there. The part number is on the screen now. That's the one that had the correct footprint, the correct layout. Little SOT 223, I believe it is, and that should fit straight on there. If I can open that up. There we go. And that will sit right there. Okay, so first things first, You want a bit of flux on there, so give that a good blob. Bigger the blob, better the job. And then what I like to do is use some thin tape. I'm just getting myself sorted out here, and to tape the thing down and then just tack one corner. So if I grab my part with some thin tape and I can position it perfectly, about there I think, and that's going to hold it in place. And I can come in with my soldering iron. Give it a tiny bit of solder. I've actually got some really thin solder I should be using, but yeah, like that. That'll do it. And take that tape away and I can solder the tab at the top. Got that wick underneath there. And we're pretty much done. That's it. Beautiful. Probably a little bit too much solder. I should have used a thinner solder, but like I said, bigger the blob, the better the job. That's fine. You don't want to have huge blobs on there, but that's perfectly serviceable. And then next, we just get some isopropyl alcohol on our Kim wipe. I use Kim wipes because they're really nice. They don't leave lint everywhere. I buy them myself. I'm not sponsored. I just am a very happy customer. Get rid of all that flux so it doesn't cause any problems, and it's just nice and clean and neat and shiny. Perfect. Alright, let's put this thing back together. Alright, case is back together. It was really easy, just a few plugs. Nothing can be plugged in the wrong way around. It's all different sizes and shapes. 5 or 6 screws. Actually, it's 2 screws for the circuit board and 5 for the back panel, or to hold the 2 cases together. And it's all in one piece. So we've got the power supply coming in. Obviously, I don't have the original one because I blew it up. But this is going to my my benchtop power supply. At the moment, we've got it set to 12 volts because the input is 9.5 volts to 12 volts. Center negative. Center negative. The reason they do that is because the DC jack itself can switch between battery power and input power relatively easily if you have the center negative. But yeah, so I'll just sort that out myself afterwards. Be able to get a 12 volt power supply. Probably even got one on the shelf behind me, and I'll just switch the cables around. Sorry, switch the wires around inside the cable to flip that polarity. But let's turn it on, see what happens. And it's on, and we're drawing the same amount of current because it's just not very much to bring us display up. So let's hit the print button and see if this thing prints. Oh yeah, it's coming out, it's printing. Going pretty good. We've got about 0.5, just, yep, 0.5, 0.6 amps. And what do we got? Oh, it's working perfectly. Awesome. So that's pretty much it for this video. We got it working. This is go back into service to label more stuff. And yeah, I'm happy with that. 2 enthusiastic thumbs up. Alright, if you like that, we'll see you in the next one.